Piles are extensively used for bridges and buildings as foundation elements, especially for high rises. Cast-in drilled hole piles are generally more economical than most other types of piling. They can be precisely tailored to particular requirements and suitable for almost all site conditions. They are commonly chosen. Post-grouting is applied for board piles primarily to enhance the pile load-bearing capacity, which reduces the number and length of conventional drilled shafts. It has proven to be highly effective, offering significant benefits with relatively minimal additional costs. Over several decades, PGDS technology has continued to develop worldwide. The first reported pile post-grouting was at the Maracaibo Bridge in Venezuela in 1961. A similar system was later used for bridge foundations on the Parana River in Argentina. Dr. Arnaldo Bolognesi described the post-grouting details of the Parana Bridge, and presented at the 8th International Conference on Soil Mechanics and Foundation Engineering in 1973. This could be the first public technical report of the PGDS technology. In 1986, Dr. Donald Bruce, the recipient of the 2015 Terzaghi Lecturer Award, published Enhancing the Performance of Large Diameter Piles by Grouting, in Ground Engineering magazine, which would be one of the most frequently referred to materials in following studies. Dr. Bruce mentioned in the end, continuing developments in grouting technologies on the one hand, and the increasing demands placed upon piling specialists on the other, suggests strongly that the role of grouting in enhancing pile performance will continue to grow in the years to come. In China, the development of pile post-grouting has progressed in line with the world. A milestone was achieved in 1997, with the successful application of closed-type pile grouting at the Huqiu River Super Bridge, led by Weiji Gao, the founder of Dato Pile Technology. In the same year, 1997, professionals from institutions across China gathered in Yangzhou, for a pile post-grouting seminar. The event was attended by Dr. Zhou Jing, an academician of the Chinese Academy of Engineering, who expressed strong support for this new technology. Weiji Gao proceeded with a research report at the meeting. It was an influential action to move the technology forward, and pile post-grouting started to prevail in China since then, like the post-grouting practice of Sutong Bridge at Lower Yangtze River. U.S. guidance referred to. According to U.S. Department of Transportation, Federal Highway Administration, Evaluation and Guidance Development for PGDS for Highways 2017, PGDS is classified into two types, open-type grouting, and closed-type grouting. European standard describes pile post-grouting in the similar way, in EN 1536, 2010, Execution of Special Geotechnical Work, Board Piles, Chapter 8.410. The pile post-grouting maintained as either open grouting, or closed grouting, till 2017. In 2018, a new post-grouting technique for pile foundations was invented in China by Weiji Gao, the pile tip, open type and closed type combined post-grouting technology, designated as POCC post-grouting technology. This invention resolves the historical either or dilemma between open and closed grouting methods in post-grouting of pile foundations, achieving systematic integration and functional hybridization of these two approaches. It inherits the inherent advantages of both methods, while generating substantial synergistic advantages through their interactions. This integration not only combines the methodologies of predecessors, but also combines their cumulative efforts and wisdom. The POCC post-grouting, a three-stage grouting process. The first stage, open grouting, similar to sleeve port grouting, or tube à manchette in Europe, involves injecting grout from the base of the pile. During this process, the grout mixes with the sediments at the pile tip, and flows upward along the borehole wall. Once the grout cures, the shaft friction resistance is enhanced thereby. Connecting the grouting lines to closed grouting pipes. The second stage involves closed grouting, similar to flat jack grouting. During this process, grout is injected into the expandable capsule positioned beneath the reinforcement cage, which hardens to create a cement stone reinforced enlarged pile tip. Meanwhile, as the capsule expands, it compresses and redistributes the injected grout radially around the pile tip, where it interacts with the mixed sediments, to form a homogeneous cemented soil composite. Connecting the grouting lines back to open grouting pipes. The third stage involves another open grouting at the pile base. As the sealing capsule expands, it creates a plug that restricts upward grout flow. The pressurized grout subsequently propagates downward through hydrofracturing and permeation, forming root-like cementitious veins. This process enhances soil stabilization at greater depths by inducing deeper soil cement matrix consolidation. Specialized devices have been developed for POCC post-grouting applications. These devices consist of three primary components: a ring-shaped steel plate, a tire-like expandable capsule, and a grout distribution piping system to deliver grout inside and outside the capsule chamber. The hollow central design of the device ensures a smooth cage lowering to bottom operation in wet bore slurry, while avoiding turbulent flow disturbances to the bore wall, caused by the piston effect of solid plate like the traditional flat jack device. This hollow center configuration also provides the access for bore cleaning operations. Through a sequenced high-pressure triple grouting protocol applied at cast-in-place pile toes, POCC post-grouting technology maximizes the enhancement and mobilization of bearing capacity potential within the stratum of pile base. Here are a few highlights of POCC post-grouting technology. Complete elimination of sediment and silted deposits at pile toe. Under the action of three-stage POCC post-grouting, all silted deposits including pile end sediment have been completely eliminated and transformed into a hardened cement soil matrix. Enhancement of shaft friction resistance in surrounding soils. The shaft friction of the surrounding soil within a specific vertical zone, extending upward from the pile tip, has been significantly enhanced. Improvement of stratum strength and ground bearing capacity. Through the multi-stage high-pressure grouting treatments, significant enhancement has been achieved in both the strength of peri-pile strata surrounding the pile tip, and the overall foundation bearing capacity. Pile tip enlargement. The expansion of capsules forms a cementitious bulb at the pile tip, effectively enhancing the contact area between the pile toe and bearing stratum. Intensified pile-to-stratum interaction mechanism. The enhanced intimate contact between the pile and the toe-bearing stratum enables structural loads applied at the pile head to be efficiently transmitted to the stratum, thereby activating the toe resistance mechanism at earlier loading stages, with greater effectiveness. This fundamental interaction transforms conventional friction piles into end-bearing friction piles, friction end-bearing piles, or even pure end-bearing piles. POCC post-grouting technology demonstrates highly reliable stability in enhancing pile performance. It provides strong confidence in pile optimization to achieve significant cost efficiencies with reduced pile lengths, diameters, and quantities. Compared to conventional piles, the POCC post-grouting technology is expected to reduce piling costs by up to 30%, while also significantly shortening the piling construction lead time. The substantial cost savings not only deliver economic benefits to real estate developers and infrastructure investors, but the significant reductions in cement and steel consumption is also a contribution to green development and sustainability. Probably POCC post-grouting can be considered as a leap in geotechnology, as stated in 2015 Tertsagi lecturer by Dr. Bruce. It may not satisfy all the criteria, but obviously it is not an incremental development, and it comes with vision, courage, and intensive site practices over 30 years. POCC post-grouting technology is widely recognized with technical patents from many countries. POCC post-grouting technology has been successfully used in many projects in China. Time for POCC post-grouting technology to benefit more people worldwide. We are more than happy to work with you, to develop buildings to a new level. Thank you.